Welcome back to Online Learning 8th grade math. Boys and girls, I'm learning that whenever we start a brand new year, it is better to start with a review. And what better way of reviewing than to return to translations, reflections, and rotations. I'll repeat that. Translations, reflections, and rotations. These three terms are critical in moving forward with our unit this month. For starters, we use translations in language. A translation is only a way to transfer. For example, if I am from Japan, which I'm not, and I wanted to come to the United States, I possibly may not even know the language in the United States. So I would need someone to translate for me, to help me understand, or for people to understand me and the way that I speak. So that is what I mean when I say a translation. So when I translate a shape, guess what I do when I translate a shape? I'm going to move it around. When I translate, I'm taking that shape and I'm moving it around just like I would with a language, trying to learn it, trying to figure out my way. So translations is nothing but movement, moving that shape around. Now, when I do a translate, I can move it up, I can move it down, I can move it left, I can move it right, I can even loopy-loop it if I want to. So I'm not changing how that shape looks at all. Notice that nothing changed about the look of the shape. The only thing that changed is the transformation, but the look stays the same. Now you should understand what translations are. Now let's move into a reflection. Let's move into a rotation, then I'll come back to reflections. With rotations, well, before I go into what a rotation is, let me first of all tell you there are three kinds. We can rotate outside of the shape. A rotation can occur in the middle of the shape. And a rotation can occur on the corner or the vertex. Now, let's talk about outside of a shape. When it's outside of a shape, that means it rotates at a point, and we call it a turning point or a circle or a center of a turning center. So what we would do when we find out that turning point, what we would do, we could place a, let's see, imagine that, I'm just going to put my little dot right here, and imagine that there was some type of link between this triangle and this point. Let's go ahead and name this triangle. We'll name this triangle Justin, and I'll turn it around here so you can see its name. This Mr. Justin, and say this is Naisha, all right? And in order for a rotation to occur on the outside of the shape, we can rotate Justin around Naisha, but the shape doesn't change. So Justin would just rotate around Naisha on the outside of the shape. So that is what we call a rotation. Everybody understands that? Now, there are two other kinds of rotation. A rotation can occur in the middle of the shape. So with this one, let's see the magnet. I can put the magnet right here in the center of the shape, and then it will turn like this. So all it's doing is just rotating, and it's right there in the center, but it's still moving. It doesn't change the shape. It is just nothing but a rotation, and it's occurring in the middle. So, middle of the shape, rotation. Now, a rotation can also occur on the corner or the vertex. These are the vertexes of this particular shape. This is the corner. These are the vertexes. So if I take my magnet and I put it right here on this corner, just like this, what do you think is going to happen? We can still rotate that magnet and rotate that triangle. My point is on one of the vertices, so it turns. So it's going to turn and it's going to look like this, but it's in the corner, but it will turn. And it will still rotate. Quite simple. Very simple. I'm keeping it very basic for you right now so you can understand what I mean by a rotation. Now, so let's review. Rotations can occur outside of the shape, middle of the shape, and on the corner of a shape. Now, let's talk about the degrees to which this rotation can occur. A rotation can occur 90 degrees, 180 degrees, 270 degrees, or 360 degrees. If the rotation occurs 90 degrees, say if this is our starting point, and if that rotation occurs 90 degrees, that means it's 1/4 of the way. So it's about right here. That's 1/4 of a turn. If the rotation occurs 180 degrees, then this starting point is going to move straight down, just like that. So now we're sort of like halfway, 180 degree turn. If that rotation occurs at 270 degrees, it's going to start, let me back it up. It's going to start here, then it's going to move here, then it will move down, and then it will do one more turn. That's 3 turns. So in essence, you're taking that 90, which was the first one, and you're adding 90, and then another 90, and then another 90, which is going to give us what? 270. So it's 270 degrees when it turns 3 times. That would be equivalent to a 270 degree angle. And lastly, if it turns all the way back up to the starting point and makes it all the way back, that means it is at 360 degrees. That means it had a starting point and went completely around. So that would be 4 out of 4. This would be 3 out of 4, the 270. So that is what I mean when I say a complete rotation. Hope that was understandable. Now let's talk about a reflection. What do I mean by a reflection? A reflection is a mirror image. A mirror image. It's just like looking in the mirror and seeing yourself. So if I want to take this triangle and create a mirror image, it's just like taking a line and placing it on this side. And if I take my triangle and I turn it this way, then I have created a mirror image of what my triangle would look like on the opposite side. A mirror image from here to here, which is on the opposite side. So that would be what we call a reflection. I hope you guys understand that. If at any time when I'm speaking to you, if you don't understand, please let me know, because I'm seeing that that you all are grasping the information, but I need to make sure that you understand that it is a mirror image, and that is what I mean when I say a reflective. Now, the last thing that I want you to know is what we call complex transformation. Complex transformation. And for 8th grade, that is where the challenge is going to come in, because we have to use all of these when we get into a complex transformation. We have to use translations. Remember how it moves around. Reflections, the mirror image, and the rotation. So complex Transformations involve all of those things, so it might mean taking a shape, just like this shape right here. It may mean taking that shape, figure out how it can go up. What makes it go up? What makes it go right? What makes it go left? What makes it turn? You might say translate instead of movement. How it translates? Does it rotate inside the shape? Does it rotate? Does it translate up? Or how does it rotate? So I've given you the foundation of translations, reflections, and rotations. Now, this is what I would like for you to do as we continue digging deeper, because that's what we do in in eighth grade. We did. I know third grade. Oh my God. That's what we do in eighth grade. You seniors, remember, you're preparing for the ninth grade. You want to be excellent. And that's what we represent, nothing but excellent and enrichment. So once I give you the basics and the foundation, and this is a review, all you're going to do next is upload those YouTube videos that I will be placing in the Google Classroom. I need you to watch the videos and work the assignments in there for the week. Also, when we have our weekly meetings, I need you to pay attention as I teach the context to you or the content to you. And I want you to enjoy math because this is just the beginning. See you tomorrow. Have a good day.